Hi, on today's tutorial we are going to explore how strings are represented on a PC and how can we create and interact with them using Julia. So a string is in fact the digital representation of written text, and writing is the physical manifestation of our own spoken language. It was the first method that we, as humans, created to allow to preserve and share complex information and ideas. It was such an important creation because it allows us to create very specific information in a lossless way that could be stored and possibly replicated for more than one's lifetime. Of course, nowadays, this information is stored digitally and is made to be accessible by not only persons, but also machines. For example, one of the most crucial usages of text recently has been to train large language models, as for example, OpenAI's GPT. These models were trained with written human knowledge that can be as old as thousands of years ago. Data is stored in a digital media as bits. Each bit can store two states. We usually define both as 0 or 1, or even false and true. These bits can be aggregated in 8 in order to create a byte that can have 256 states. Now, this is already enough to encode a letter and to be used as storage and communication of text information. A popular standard arose on the 60s called ascii that eventually encoded text with 1 byte per char. In order to use this standard, you first need to know the text starting memory position and then read byte per byte till a null value. A null value is just a byte where all bits are 0. As you can see on the example below, a simple hi can be encoded in 3 bytes with the bits in the values that I have defined in the yellow boxes. But how do we know these values? Well, there is a table that allows us to encode a letter, number, or instruction on a single byte. So you can see here, on the left, we have a couple of useful instructions, as for example, a new line information or a tab. Then, on the next column, we got some punctuation, numeric nomenclature, also numbers. Then we have, on the next one, uppercase letters and then lowercase letters. This is the original 7 bits version of the ASCII table. There is also an extended version that uses the full byte. So why don't we use only the ASCII encoding? Well, because it only covers the Latin alphabet, and the world speaks a lot of languages with different alphabets. A solution to this problem was found by the Unicode standard that allows it to cover 161 different alphabets. Also, emojis. This is now encoded into a variable size char that can take 1 to 4 bytes in UTF-8. There is also a fixed length version called UTF-32, but it's not as common because it takes more storage space. For UTF-8, the number of bytes of the char is encoded on the first bits of each byte. On Unicode, it's also common to use the null char to define the end of the string. Now let's go to Julia and test some chars and strings. So let's first see how a char works and then we go to the strings. So chars to string. So in order for us to define a char in Julia, we use the apostrophe here. So for example, hey. And you can see here on the bottom that it is an ASCII Unicode with a given number, 0061. This value is actually in hexadecimal. And the type of this char is then, of course, char. So if you create a second char, instead of being A, it's going to be B. How could we join these two together? So would something like this work? String 1 A, B? No. The apostrophe, it's only for chars. If you want to define a string, you are going to do it. So quotes A, B. And this time around, we have a string. We could also join both chars together. How to? Well, we can do it like this. So char 1 multiplied by char 2, and it's joined together with these codes over here. Of course, just to be sure, let's type off string 1 and we got a string. So just for curiosity, let's see how Julia saves this string on memory. For that, I'm going to use a function here that is a little bit unsafe. And the name is actually unsafe because it's going to use pointers. And pointer is not something usually used on Julia, but it's just for you to know how it is set on memory. So what we have, it's going to be an unsigned int 8, so it's just a byte in our case, and I want to know the location, so the initial location of this string in memory. Then I'm going to extract the next 3 bytes on memory because my string has A, B, and then we got our additional null byte. So for that, I'm going to unsafe wrap. So these functions, these unsafe functions, are here on Julia mostly to interact with the C code that also use pointers, but usually you don't need to use those. I'm just using in order for you to see what is on memory. So I'm going to pick up a vector starting on his pointer, and now I have to get 3 of these unsigned ints. So what I have here is then 61, as you can see, the Unicode for A, 62 Unicode for B, and then our null byte. Perfect, this is exactly what we have seen before. Now, I did use directly the letter that I want to create by creating my variable char, char1 and char2, but you don't need to. You can use, for example, the binary representation, the decimal representation, or the hexadecimal representation. So char1 can also be written as char 061, as we've seen here on the top. And this will also give us A. Or we can also get the binary value of it. For the binary value, let me just quickly check. String int of char1. So this is the decimal value, can also be used. So base 10. Char1 can also be char 97. And then for the binary, it's going to be string int char1, but now base 2, so binary. Okay. So there are 7 numbers here. We can also put the 0 if needed. Char1. It's going to be binary in this case. So for binary, just use 0b and then the value. Perfect, same thing. And you can also add the extra 0 here. It's going to give the same value. Now let's create some strings. String usage. How can we type a string here on Julia? There are many ways to do it. Let's check if we need multi-lines. So line 1 and then line 2. This allows you to create a string that got 2 lines. So here you got the raw version, but if you use print, you're going to see here the new line. Also, in some situations on Windows, you might also use a new line and carriage return, okay? So on Linux, it's only the new line, but in some situations, this might be used. If you need to use some special characters, so for example, the codes, you can check that we already are using the codes to define a string. And what if it happens inside of the string? So if I do it like this, a code here, well, I'm just going to create an error. So these codes inside of the string need to be escaped. And if I do it like this, then it will work. I can also print it, print string 3, and you can see that the codes only appear on characters. We can also use emojis. So I feel something today. Let's select an emoji here. And for emojis, you can just hit your Windows dot symbol, and then you can select the emoji. So let's start with something. Then I'm going to put this emoji smiling. What is important to understand here is that we can also extract the char of the string. So for example, the first one is going to be I, and you can do it like this. Oh, sorry, it's complex string. Okay, perfect. And you can check that, yes, I'm getting the first one, I could also get the second one like this with a space, and then the third one as well, F. But then I'm going to up to 8, where I got my emoji. And what happens if I put 9? Is it going to be the next char here, a space? No, I got an error. Why do I got an error? Because the emoji takes 4 bytes. So Julia uses UTF-8 for encoding, and UTF-8 has a variable size for each char. If it is something like a letter on the English alphabet, we only use 1 byte, but the emoji takes 4. So I cannot use like this, because I'm getting the 9 bytes of this complex string, and that 9 bytes still belongs to the initial emoji on 8. So what are my solutions here? How can I get the next space here? Because maybe I didn't add the idea of the emoji being there. What is my option to get, for example, all the chars on my string without getting an error? So one solution is to get the char indices. And for that, I can just collect each index on my string. And as you can see here, oh, actually, I cannot. Let's print this. And as you can see here, I go up to 8, and then as the emoji takes 4 bytes, it goes to 12. So now if I take my index like this, string 1, index 8, then I'm going to get my emoji, and then if I use the next one, I'm going to have the next char on the string. So this is a solution here. Collect the indices of the string for each char. Another possibility: transform string into a char array. So let's get all the values of my string here as chars. And what I got here is a vector of chars. And we got 14, so all the chars here, not the number of bytes, only the chars. And then I can pick it up, the char array 8, and maybe change it to something a little bit more happy. So let's see what I got here available. So this one looks good. So I just changed the index 8, so the 8th char of our string, and then I can join together all the chars again with the function join, and I will change that specific value here. Okay, perfect. Also, I didn't show, but you can also pick up the next value here, and we don't have an error. So let's also show how can you use a variable inside of a string. So variable in a string. So for example, I want to create a string where we got values from 0 to 10. So we can do like this. X is going to be 0 to 9. So I got all the values between 0 and 9 here. But what I want is a variable that gives us all the values in a string from 0 to 10. So let's start with 0. And then I'm going to create a for loop here. For all the values that I got on X, I'm going to define my variable 0, 10. And I'm going to join for every value on my range here on my string number 0 to 10. So let's do like this. So this multiplication is going to join both strings. So the first string is 0 plus a bit of a space here. And then I'm going to get my variable. For that, $, and then my variable. And I did create from 0 to 9. I want to start on 1. So let's just add. And you can do it like this. Let's end our loop and let's give it a go. So how does the string looks? From 0 to 10, all the values. There are also some functions that you can use on strings. You can compare two strings. So true equals true, true. But this one, the last one, the result is Boolean. The other ones are strings. It's true, different than false. It's true as well. We can also read strings from files. So let's also read a file here. Read text to read.txt, and let's create this file first. So the string just going to be some numbers. I'm going to create these numbers with a space between each one. Let's save it. I did save it on the same directory as my script here. So if I read it now, I'm going to have a lot of different values, but don't worry, we can read these values as a string as well. So txt string is just going to be the function string of my text. And now I got the same string as I had on my text file. I can also pick up those values on a string and convert it to integer. And for that, I'm going to use the function parse. And I'm going to parse as int. And I'm also going to use the function split to pick up my file and separate all the values that have a space. So I'm going to show this part first. If I separate all the values, I'm going to get a vector of substrings, so part of the original string. And now I can convert these values to int to get an int vector here. And just to show that it is an int, I can, for example, add 1 to all of these values without an issue. So more functions. Let's imagine that we got a string that has some issue. String with an issue. I got too much words in caps, and I also got these commas over here that I want to remove. To do that, let's create a new string where I'm going to replace all the values on string 5 that have a comma by, I guess, a space. So now I got only space. I still have the caps issue. To solve it, I can put everything in lowercase first. Okay, and then the first char should be on uppercase. I can use the function uppercase first. And here we go, perfect string now. Another thing that is very important on a string is to do some search. To do that, string that is going to have get the, and then a tag, equation. And that equation is going to be 2. Also, in order for you to use a symbol, it's backslash and then the name of the symbol. So 2pi end of equation. And what I want to get from this string is just the 2pi, this equation between these tags. So for me to get that equation, first I need to get the index of where does the tag first appear. So find first the tag equation. And we know that it starts on 9 and ends on 18. And I want to do the same thing for the end of this tag. So the end tag starts on 22. Now I know that my equation is somewhere between 18 and 22. And then I use something like this, where I'm going to get the index start for the last value, plus 1, because I want to start on the equation. And does this make sense first? Let me show to you. 2, so it's the 2 from the 2 pi, up to the index stop the first value minus 1, because I don't want to start already with a tag. Will this work? No, same issue. The pi here uses 2 bytes. So what is the solution here? So the solution is to make it like this. Instead of adding 1 and removing 1, I want to get the next index and the previous index. You can do it like this. Next index for the string complex string 2. And I'm going to remove plus 1. And here, previous index for control string 2, index stop 1. And now I don't need minus 1. Oops. Okay, perfect. Now the result, it's 2 pi. Another way to do this, another way for search, and usually it's better for something more complex, it's regex expressions. So if I had to do this with regex, it would look like this. Match, and for a special regex string, we start with an error equation, and then I want to get what is inside. It's going to look like this, and the tag ends with equation. So what this regex string does is I'm going to grab what is inside of these 2 strings over here, and I want to apply for my complex string 2. And as you can see, there is a match for my regex, and it's 2 pi. If I want to get this value, I can also use it like this. So the equation, it's going to be regex captures the first value, 2 pi. Okay, perfect. This should be enough for you to get the basics of how to create strings, how to handle chars, how to handle Unicode on Julia, and I hope to see you again on the next tutorial.